Hello folks, we come to the part 5 video of this exercise 1.4 and let's take the question number 5. The question number 5 says that you have to be they are giving you an operation star which is defined on the set 1, 2, 3, 4, 5 such that it is HCF of AB. You have to check whether this is the same as the operation which was defined in the question number 4. So in order to get that conveniently, we are going to make the draw the operation table, and let's see how the operation table is going to come. A star B is HCF of AB. So between 1 and 1 the HCF is 1. 2 and 1 HCF is 1. Between 3 and 1 HCF is 1. Between 4 and 1 it's 1, and between 5 and 1 also it's 1. Then between 1 and 2 HCF is 1. Between 2 and 2 it's 2. Between 3 and 2, because they have no common factors, it's 1. Between 4 and 2 the common factor is 2, so it's 2. Between 5 and 2, because there's no common factor, it's 1. Then between 1 and 3 it's 1. Between 2 and 3 no common factor, so 1. Between 3 and 3 it's 3. Between 4 and 3 no common factor, so 1. Between 5 and 3 no common factor, so 1. Then between 1 and 4 it's 1, and between 2 and 4 it's 2 common factor. 3 and 4 no common factor, 1. 4 and 4 common factor is 4. 5 and 4 no common factor, so 1. Then between 1 and 5 the common factor is 1. 2 and 5 there's no common factor, so it's 1. Then between 3 and 5 there's no common factor, again it's 1. Between 4 and 5 no common factor, 1. So 5 and 5 common factor is 5. So this is the operation table that we get over here, and this operation table is same as the earlier one. If you could compare this operation table with the one that we had seen earlier, yeah, it is exactly identical with what we had done earlier. So that's the question. The question says whether it is identical to the one that we have done earlier. So yes, the answer is yes, it is identical. It is the same as question 4. That's what they say. Whether it's the same as question 4, yes, it is the same as question 4. So that's what we are answering over there. Once we are done with that, we are taking the question number 6, and in the question number 6 they are defining A star B as the LCM between A and B, and they have given us a group of questions. So let's answer that. First one, they are asking us what is 5 star 7. So 5 star 7 by formula or by definition is LCM of 5 and 7, least common multiple between 5 and 7. So between 5 and 7, whenever you have two co-prime numbers, always it's a product, the LCM. So it's like 5 into 7, that is 35. Again, 20 star 16. So that is LCM between 20 and 16. The LCM we all know how to find out 20 and 16 LCM. 4 is a common factor. 4 5s are 20, 4 4s are 16. 5 will remain as it is. This will be 1, 5. Generally LCM means you should do with prime factors, but once you are little bit confident about the numbers, maybe you can work like that. But to be on a safer side, you should always take prime numbers when you take the factors. Anyhow, so the LCM is now working to 5 4s are 20, 20 into 4. 80. The LCM is 80 over here. Now routine method of finding the LCM, we are finding it, we are getting the value as 80. Now we have the second subpart where they are asking us to check whether star is commutative. It is commutative. Why? Because consider, suppose if we consider A star B. A star B means it's LCM between A and B. And what is B star A? It is going to be the LCM between B and A. LCM between A and B and LCM between B and A is the same. It doesn't change. So therefore, A star B equal to B star A. So star is commutative. Star is commutative. Now, next is to show star is associative. So let's consider A star B star C. So A star B, it's the LCM between A and B. Star C, that means it is the LCM between LCM of AB and C. See, that is hardly any matter. You know, you take two numbers, get its LCM, and then its LCM you find out with the LCM of the third number is as good as finding the LCM of all the three numbers at one stretch. It is the same. We will, if we have some examples, we can actually sit and work out, and we can find out that the LCM will be exactly the same as doing it all together. You take 2 and do the LCM, and then take the third number, get the LCM. It's as good as taking all the three LCM at all the three numbers at one stretch and finding the LCM. It's the same thing. So that's the LCM. So it's the LCM. So LCM works out as this. And when we also consider A star B star C, same idea. A star, first you will see the LCM of B and C. We'll be making our continuation there. So then if we want, we will say LCM of A and then LCM between B and C, but that is really immaterial. It's as good as saying LCM of A, B, C. So like that, those three, A star, B star, C becomes equal to A star, B star, C. So that way star is associated. Then with the star identity, what is a star identity? First of all, you have to, it's not very necessary that it should exist. We'll find out whether it is existing, and let's see. A star E to be equal to A first, and let's see if that happens. That means it is LCM between A and A should give back A. When can that happen? That can happen only if E is 1 or so, right? Because whenever you have any number and you have 1, then automatically the LCM will be, least common multiple will be the bigger number. So in this case, E can be 1. Similarly, if you take E star A equal to A, that time also E will come as 1. So therefore, identity is 1. Now, then they ask us whether everybody is invertible. If there are invertible elements, find the inverse. Now, for invertibility, you have to check A star B equal to 1 equal to B star A, if that exists. For A belonging to whatever set, yeah, that they have started with. What is the set that they have started with? N. For A belonging to N, suppose if we have like this, that means it's like LCM of AB is 1. Leave the other side. The other side is okay because it's commutative. So LCM of AB is 1. Which, how can the LCM of A and B, suppose a number like 10, say 5. LCM of 5 and some other number, how can it be 1? It will be minimum 5, right? Least common multiple we are doing. So unless these both numbers are 1, now that cannot be an inverse. Okay, so this is not possible. This is not possible. So elements are not invertible. Right? It's not invertible. That's what they have asked us, whether it is invertible. Are not invertible. Maximum, if you want, 1 can be invertible. The others are not invertible at all. So that's about the thing, and we end this video, the next 2 problems in the next video. Thank you.